Yes. Now we are going to see the graph coloring. Graph coloring is a process of assigning colors to the vertices of the graph. Okay. So graph coloring means you are assigning a color. So consider this graph 1, 2 and 3 and 4. Okay. Now it is connected like this. Okay. So they says that graph coloring is a process of assigning colors to the vertices of a graph such that no two adjacent vertices are assigned the same color. In a graph coloring, they says that the adjacent vertex, what is the adjacent vertex of A? So this is A and this is B and this is C and this is D. So no two adjacent vertices are assigned the same color. So this should not be same. A and B are neighbors, right? And this is also called as an adjacent vertices. This adjacent vertices should not be the same color. So if this one is blue and this one must be red or some color, and if B is red means then this should be blue. Okay. So but this A and D are not connected, so you can give the same color for here, white and white, and A to C, this one also white. So what I am doing is I am giving different color to this. Okay, so graph coloring is a process of assigning color to the vertices where the two adjacent vertices are assigned the same color. No two adjacents are, okay, no, that means you should not assign the same color for these two adjacent vertices. This is called graph coloring, or it is also called as a vertex coloring. This is also called as a graph coloring, or it is also called as a vertex coloring. It ensures that there exists no edge in a graph whose end vertices are colored with the same color. Okay, it ensures that no edge in a graph whose end vertices are colored with the same color. That is, this edges end with D and this edges end with A. This should not be the same color. Okay, this should not be the color of B. Okay, such a graph is called as properly colored graph. Such a graph is called as properly colored graph. If I colored like this, then this graph is called as a properly colored graph. Okay, graph coloring is a process of assigning color to the vertices of a graph such that no two adjacents are assigned the same color. This is also called as graph coloring or vertex coloring. Okay, where the two end vertices are colored with no edge in the graph whose end vertices are colored with the same color, and such a graph is called as properly colored graph. So wherever these applications are used, that is in a map coloring, or if you are scheduling a task, like TikTok. So if I scheduled for X here means I should not assign X again here. So I will place here. So I should not place this adjacent the same one. So I will place here. So like this, scheduling the task, map coloring, or in a game, TikTok. Okay. So like this, preparing timetable. So when I am allocating a particular subject, you should not assign for that adjacent to anyone. If I am assigning person 1 to English, so I should not assign this English subject to any one of the person, right? So that is very helpful this application, graph coloring application. Okay, so preparing timetable, scheduling the task, and map coloring and assignment, or if we have any conflict resolution or Sudoku. So these are all examples for graph coloring applications. Okay, so here you see this is a simple example of graph coloring. You can assign whatever color you want. Here it is blue and orange, rose and blue and green and all. You can assign every node maybe different color. But what is the next chapter what you are going to see is chromatic number. Okay, you can assign here the 5 colors, right? But the minimum color required is, okay, the minimum number of colors required to properly color any graph, which is called as a chromatic number. It is a minimum number of colors required to properly color any graph. That is called as a chromatic number. For example, take the same graph. Here they used 5 colors, but here you can see this So this is orange, the adjacent of this I am giving blue, and then so then I am again using this orange color, and this orange you cannot use here. Okay, this is different, this is yellow. So yellow and orange. So if I use orange here, it will be violates the rule. If I use the blue also, the adjacent color will be same. So I am using here the different color. Okay, so here it is an orange, and this is blue. So the chromatic number is minimum I need 3 colors to draw this. So it's a minimum number of colors required to properly color any graph. Number of vertices in a cycle graph is E1, then it is chromatic number equal to E1. Okay, this says that if number of vertices in a cycle graph, see if in a cycle graph, if it is even number, if it is 4 means only 2 colors are required. See, it is an odd number, so it is required, then it is chromatic number is 3. In a cycle, this is a cycle, right? In a cycle graph, if the vertices is even number, then the chromatic number is even. If in a cycle graph, if the number of vertices is odd, then its chromatic number is 3. Okay, that is a chromatic number, which is a minimum number of colors required to properly color any graph. If number of vertices in a cycle graph is even, then it is chromatic number is 2. If the number of vertices in a cycle graph is odd, then it is chromatic number is 3. And one more interesting is chromatic number of any complete graph is equal to number of vertices in that graph. So what is complete graph? In a vertices which is connected with every other vertices in the graph, then it is called as a complete graph. For example, this is A, B, C, D, 4 vertices are there. A is connected with B, C and D, and similarly B is connected with A, C and D, and C is connected with A, B, D, and D is connected with A and B and C. So this is called as a complete graph. So the chromatic number of any complete graph is equal to number of vertices in that complete graph. Okay, so the chromatic number for this graph, how can you give? So because here it is a 3 adjacent lines, right? So I have to give here one color, here one color. Okay, so here one color. Okay, 1, 2, 3, then 4. So I have to give 4 colors, then only no adjacent will be cross each other. So the chromatic number for complete graph is always, chromatic number of complete graph is always equal to number of vertices. Chromatic number of complete graph is always equal to number of vertices. That is, here it is a 4 vertices are there. So the chromatic number of this complete graph is 4. And chromatic number of any planar graph. Chromatic number of any planar graph is always less than or equal to 4. So what is planar graph? Which is not intersect with each other. So no edges or intersect with each other. Okay. So for this planar graph, chromatic number is, if this is a planar graph, okay, so no edges or intersecting with each other. For this also it requires how many? So here for any planar graph, the chromatic number is always less than or equal to 4. Always less than or equal to 4. They says that if it is a planar graph, the chromatic number is always less than or equal to 4 for planar graph. Okay, if you see here, if I give color here 1, and then here you can give different color, right? And this should not come here, and this you can, so here it is always 4. So this one also need 1, 2, 3 and 4 color is red. The next one is chromatic number of a bipartite graph. So what is bipartite graph? You are dividing into 2 sets, and one set must be connected with other set, and same set should not connect with each other, right? So this is one color, okay, and this should be another color, and this is not connected with each other, right? Set X should not connect with set Y. So second color. So chromatic number of any bipartite graph, if it is a bipartite, that means always the color is 2. So only 2 color is required for any bipartite graph, and also for the tree data structure also always it is 2 color. Okay, so this and all I can give blue, and this I can give orange, and this I can give blue. Okay, so tree is also called as an bipartite, similar like bipartite, and the color of the chromatic number of tree is also 2. So yes, here it is given chromatic number of any tree. Okay, so this one is also one tree, and this also one tree. So this chromatic number of any tree is also called as 2. Okay friends, thank you. All the best. Any queries or suggestion, you can mail us, or you can join our Telegram channel. You can type your queries or message it to my WhatsApp number. All the best, friends.